So we're going to continue talking about planes, writing equations of planes, objectives. Objective planes. So what we learned so far, we start talking about lines, equation of line, and then we introduced a plane. Equation of a plane is written as A times x minus x sub 0 plus B times y minus y sub 0 plus C times z minus z sub 0 equal to 0. Then we simplify that and we have ax plus by plus cz equals to d. We said that, hey, we have a normal vector with components a, b, c, and this is the point p sub 0 and the point x sub 0, y sub 0, and z sub 0. So equation of the plane with one point, and the normal vector is here. Remember that we took another point in the plane and we constructed the vector connecting p sub 0 and p, and we had a normal vector. We saw that the angle between these two vectors is 90 degrees, and the cosine of 90 degrees is equal to 0. That's why the dot product between these two vectors is equal to 0, and it actually gave us the formula for the plane. Okay, perfect. What's next? We're going to go over some examples. This example says, well, write equation of a plane that passes through 3 points. Write equation of a plane that passes through these 3 points. The first point, P, is given to us as 1, 3, and 2. The second point, Q, has coordinates 3, -1, and 6. And the last point, R, the coordinates 5 to 0. Okay, perfect. So what do we have here? We have 3 points, and we have a plane passes through these 3 points. This is our plane with 3 points in that plane. P, for example, is here. Q, for example, is here, and R is, for example, here. 3 points. Remember now to write equation of a plane. We need 2 things. We need 1 point in the plane, either one of these, and we have the normal vector. We need these 2 information. 1 point and the normal vector. Okay. We don't have any issue with 1 point in the plane. We can choose any one of these, but normal vector is missing. How do we find normal vector? To write the equation of this plane. We have our point. We need the normal vector. We construct 2 vectors in the plane. V1, V2, or V and W. V and W. 2 vectors. Why we need 2 vectors? Recall that. Recall that. When we talked about operations between vectors, we said that we can add vectors, find the difference between two vectors, we can find the dot product between them. Also, we can find the cross product between two vectors. If you have two vectors like V and W, we can construct the cross product between them. Cross product between these two vectors, V cross W. The outcome of the cross product is a new vector, which is perpendicular, orthogonal, normal to these two vectors, to vector V and also to vector W. So after finding two vectors in the plane and finding their cross product, we can then take that cross product and call it, hey, this is our normal vector. So to write the equation of this plane, we construct two vectors in the plane, V and W. Then we find their cross product and we call it our normal vector. The rest is easy. We take one of the points in the plane, we have our normal vector, then we write equation of the plane. Okay. Let us take PR and form vector B. Then we take P and Q and we construct vector W. Vector W. So vector B, PR, the initial point, the terminal point, we can write the components of this vector as, so here you have R minus P, 5 minus 1, 2 minus 3, and 0 minus 2. My vector V is 4, -1, and -2. So this is my vector. Let's construct the second vector, PQ. PQ. The components of the second vector, 3 minus 1, -1 minus 3, and 6 minus 2. This guy is equal to 2 minus 4 and 4. So I have my two vectors. The next step is to construct the cross product between them or the normal vector. So V cross W, or my normal vector, is equal to the determinant I, J, K. The second row are the components of vector V, which is 4, -1, -2, and the third row are the components of vector W, which is 2, -4, and 4. The determinant is equal to I, -4 minus 8, minus J, 16 plus 4, plus K, which is -16 plus 2. So my normal vector is equal to -12, -20, and -14. This is my A, B, and C. Take one point, like P. 1, 3, 2, x of 0, y sub 0, z sub 0, and then write equation of the plane. A times x minus x sub 0 plus b times y minus y sub 0 plus c times z minus z sub 0 equal to 0. So we have negative 12 times x minus 1. And here we have negative 20, y minus 3. And we have negative 14, z minus 2 equal to 0. So if we just multiply everything by, let's see, negative a half, we get 6 times x minus 1 plus 10 y minus 3 plus 7 z minus 2 equal to 0. So 6x plus 10y plus 7z is equal to 50. This is the equation of this plane. There you go. So when we have dot product and cross product between two vectors, you can actually use those information to find the angle between two vectors. How do we do that?